Welcome back to Basic Mathematics. In this video, we're going to be talking through some operations on whole numbers. I don't really have much to say on the topic, so let me just get my head out of the way and let's dive right in. We've already talked through the basic operations of addition, subtraction, multiplication, and division. In this lesson, I want to kind of extend those ideas and start looking at adding, subtracting, multiplying, and dividing larger numbers. So for example, if you have something like 42 plus 37, you might want to come off to the side of the expression and write out in columns 42 and 37 and add column by column. 2 plus 7 is 9, 4 plus 3 is 7, so 42 plus 37 is 79. Something a little bit more complicated. 176 plus 48. If you want to write these out in columns, be careful how you set it up so that the right-hand side of the columns line up. So we've got 6 plus 8, which is 14. I write down the 4 and I carry the 1. I have 7 plus 4, which is 11, plus that other 1, which is 12. I write down the 2 and carry the 1. Then I have 1 and plus 1, which is 2. So 176 plus 48 is 224. Subtracting works fairly similarly. If I have 192 minus, I'm sorry, I'm writing the wrong number down. If I have 197 minus 52, I can set that up column-wise as well. And subtract column by column. 7 minus 2 is 5. 9 minus 5 is 4. And 1 minus nothing is 1. 197 minus 52 is 145. Taking a look at one a little bit trickier. If I want 133 minus 87, here I immediately run into problems because column-wise, 3 minus 7 is not defined. So I use a process called borrowing. Take this 3, turn it into a 2, and borrow the 1. So I have 1, 2, 13 as the digits of the number instead of 133. And then I can subtract. 13 minus 7 is 6. Then I go to the next column and run into the same problem. 2 minus 8 doesn't work. So I borrow again. I take from this 1, it becomes a 0. I introduce the 1 there so that I have 12 minus 8, which is 4. And then 0 minus 0 is 0. We don't need to put zeros in the front of numbers. It gives me 46 as my result. When it comes to multiplying, there are several different ways that you can write out your multiplication. I'm going to show you my personal favorite, the one that I learned when I was a student and kind of the one that sticks with me. I like it because it uses the least amount of space of any process. Other processes work similarly, but use more space. There's nothing wrong with writing it out differently. As long as you're getting to the same place that I'm getting to, everything should be fine. All right, let's take a look at 123 times 45. I'm going to write this out in columns. And the rule of thumb for multiplying, or at least the one that I'm most familiar with, and most of my students have been most familiar with, is take it one digit at a time. I want to take this 5, and I want to multiply it by all of the digits over here. So I multiply 5 times 3, which is 15. I write down the 5, and I carry the 1. I multiply 5 times 2, which is 10, and add the 1 I carried to get 11. I write down a 1, and I carry a 1. 5 times 1 is 5, and I add 1 to that, which gives me 6. Then I go on to the next digit, the 4. Because that's one digit in, I move over one space. You can fill in with an X or a dot or a 0 or a line, or you can just leave the space blank. I don't like putting zeros there because it leaves me confused sometimes when the first product ends up 0. I forget, did I just write that sloppily or what happened? But because the 4 is one digit in, I move one digit in before I start writing my results. 4 times 3 is 12. I write the 2 and carry the 1. You can see that I've switched colors, and I wrote that in the wrong place. I switched colors so I can tell where my carries are. If I'm writing in pencil and I only have one color, I kind of go above and above and above and above for each line. But 4 times 2 is 8, and 8 plus 1 is 9. And then 4 times 1 is 4. Finally, now that I have this, I add all of the digits together. 5 and nothing is 5. 1 and 2 is 3. 6 and 9 is 15. I write down the 5 and carry the 1. 1 and 4 is 5. So 123 times 45 is 5,535. One thing to keep in mind when you are multiplying, the same is true in addition, although not really useful in addition. The same is not true in subtraction. But when you're multiplying, you can rewrite or change the order of numbers. So writing this out, 123 times 45 in this order, was not that bad. It took us 2 passes through. If I wanted to write out 45 times 123, technically speaking, I should write it out this way, and I would get 3 different passes through. 3 times 5 is 15. 3 times 4 is 12, plus 1 is 13. 2 times 5 is 10. 2 times 4 is 8, plus 1 is 9. 1 times 5 is 5. 1 times 4 is 4. And when you add all of these together, you get the same 5,535. But what I want to stress about this is that you can choose either way of writing out your two numbers when you're multiplying two numbers together by hand. You can write out 123 times 45. You can write out 45 times 123. You'll get the same answer. Sometimes one order or the other is better. Sometimes it really doesn't make a difference. Things to watch out for: the more digits that are in the number, the longer the process is going to take. But if you find a number that has a bunch of zeros, you can save yourself a lot of time. Remember, 0 times any number is 0. And when you have that situation to work with, it really saves you a good bit of effort. For one more example of multiplication, if I had 400,040 that I wanted to multiply by 37. I'm sorry, let's make that 376. Well, I could write that out. And work through the multiplication. Multiply 6 times 400,040, then multiply 7 times 400,040, then multiply 3 times 400,040, and it would work. But if I notice 400,040 has a bunch of zeros in it, and it has some repeated digits, it might be better for me to write the 376 in the first line and the 400,040 in the second line. Because when I multiply 0 times something, I get 0. I don't have to think about it. When I multiply 4 times 6, I get 24. When I multiply 4 times 7, I get 28 plus 2 is 30. When I multiply 4 times 3, I get 12, and I add 3 to that, and I get 15. Then in the next column, I multiply by 0. Then in the next column, I multiply by 0 and get 0 again. And then I do that one more time. I suppose I didn't even have to write these rows down because adding 0 to something doesn't change anything at all. But then my next step, I multiply by 4. And I already know exactly what's going to happen if I multiply 376 by 4. I'm going to get 1,504 because I already did it. So I don't have to think about doing it again. When I add this together, I get 1,504, 1,5040. Put some commas in to make that readable. That's 150,415,040. So thinking through how to set this up, if you see shortcuts like this, it can make your life a lot easier. Moving onward, let's take a look at some division. I'm sorry, I'm getting a little bit ahead of myself. Before I talk about division, I want to talk briefly about rounding and estimating. The idea of rounding and estimating is very simply that zeros make numbers easier to work with. Right? Would it be easier to add 4,768 plus 2,853, or would it be easier to add 5,000 plus 3,000? I hope you will all agree that 5,000 plus 3,000, without having to write out the columns at all, we can just look at and say that that result is going to be 8,000. By looking at that, I know that if I try to add 4,768 plus 2,853, I'm going to get something close to 8,000. Not exactly 8,000, but within a ballpark. That is useful in a couple of different ways. First of all, if I am trying to give an estimated cost right? Say I am a business person, I run a construction or landscaping or other kind of service um, company. I go to my customer's residence, I look at the project, and I start kind of scratching my head and trying to figure things out. All right, well, it looks like this is something around um, an area 168 feet by 225 feet that they're asking me to do some landscaping on. All right, well, 168 by 225 is some ugly numbers, but that's really close to 160 by 250, which is reasonably close to 200 by 200. So by using some easier to work with numbers, I can get the area that I'm looking at very quickly. And once I have the area that I'm looking at, I can figure out, I know that it costs my crew about $150 per square foot to come in, dig things out, put down new landscaping, put down rocks, whatever it is that I'm being hired to do. And using the simpler numbers lets me give the customer a ballpark figure without having to pull out a calculator. Estimating like this is also incredibly useful in error checking. In this course, you are not permitted to use a calculator. All of you are going to be taking a follow-up course somewhere along the line where you're going to be expected to use a calculator. Whether that's your next math course or the one after it or the one after that, at some point you're going to be looking at math where calculators are necessary. One thing to remember about calculators is that a calculator is only as good as its input. If you are trying to type things into a calculator and you make a mistake, your calculator will very faithfully perform the computation that you told it to. If you have some idea of what the answer should be, you can often catch when something goes wrong. If I'm trying to type into my calculator, add, sorry, it's over here, where I guess I can't point to it. If I'm telling my calculator to add 4,768 plus 2,853, and I screw up, and when I push the 8 key, the calculator doesn't register it, all of a sudden I'm telling my calculator to add 4,768 plus 253 instead. And I get something like 5,150. Well, quickly in my head, it's over here this time, I don't know how to gesture. Quickly in my head, I was able to work through and come up with 8,000 as an approximation. If my calculator gave me something that's far away from 8,000, like 5,100 is, I would immediately say, wait a second, this looks wrong. I'd go back, I'd look at what I typed into my calculator and make sure that it was right. So those kinds of skills are very important to you throughout what you are looking at. The general rule of thumb for rounding is that we want to look at the digit that comes next. So for example here, to round to thousands, I looked after the thousands place and saw a 7, after the thousands place and saw an 8. Right? If that digit is a 5, 6, 7, 8, or 9, you round up, as I did in this case. If that digit is a 4 or lower, you round down. So as another example, if I had 12,742, and I'm trying to add that to 3,174, rounding to the nearest thousand, I would take 12,000 and round it up because the next digit is a 7. I would take the 3,000 and change and round down because the next digit is a 1. So in my head, I'm adding 13,000 plus 3,000, which I can do without a calculator and get 16,000. You can perform these kinds of estimations in addition, subtraction, or multiplication, or division, or really any other operation. Oftentimes, these kinds of roundings are important because the numbers you're working with don't really make that much sense lower than that. We'll see a lot more in that effect next week when we talk about decimal numbers. I'm sorry, that's not next week. That's a couple of weeks from now. We'll talk about decimal numbers. And we'll see a lot more of the importance of rounding in that lesson. But for right now, I care about rounding because it's going to be vital to our process of performing division. For example, if I want to take 1,504 divided by 32. Setting this up, I will use a long division box. And start working through piece by piece. Looking at 32 is kind of challenging. So instead of always looking at 32, I'm going to estimate. Let's look at 30 instead, right? 32 rounds to 30. And 30 I can look at pretty nicely. 30 does not fit into 15, but it does fit into 150. 3 times 5 is 15, so 30 times 5 is 150. All right, so I'm going to try 5. Of course, at this point, I have to go back to the 32 that I was looking at the first place. And I need to multiply 32 times 5. 5 times 2 is 10. 5 times 3 is 15 plus 1 is 16. 32 times 5 is 160. All right, we were off. That was too big, but that got us in a pretty good ballpark. I know that 5 was too big, and it can't be that much too big. So 4 must be the right value. I'll multiply 32 times 4. 4 times 2 is 8. 4 times 3 is 12. So 32 times 4 is 128. Write down 128 and subtract it. You get 22. 22 is less than 32, and that's important. Again, you have to have something smaller here. Otherwise, it's a sign that something has gone wrong. And then we drop down the next digit, which is our 4. And we make the same procedure. All right, we round 30 to 32. We round 224. 220 maybe. All right, and then we start trying to think through what we might be able to use. Well, 3 times 7 is 21. So 30 times 7 would be 210. That's smaller than 224. 3 times 8 is 24. So 30 times 8 would be 240. That's too big. So it looks like 7 is likely to work. I go off to the side one more time and I multiply. 32 times 7. 7 times 2 is 14. Write the 4, carry the 1. 7 times 3 is 21. Plus 1 is 22. And I do get exactly 224. Subtract that off, I get 0. Nothing else to drop down. 0 at the bottom of the list. That means that 1,504 divided by 32 is exactly 47. Right? Of course, division very often does not work out exactly. Much of the time when you try to perform long division, weird things are going to end up happening. For example, let's take a look at 1,622 divided by 27. We will again set this up. 27 goes into 1,622. And we'll look one step at a time. 27 again rounds to 30, so that's going to be kind of our watch point. 3 times 5 is 15, so 30 times 5 is 150. So 27 times 5 should be somewhere in the ballpark of 150. It might be good enough for 27 goes into 162 5 times. We might be short. Only way to find out is to go off to the side and multiply 27 times 5. Right? 5 times 7 is 35. Write the 5, carry the 3. 5 times 2 is 10 plus 13 is 135. And that looks like that should be really close to working. I guess to double check, we can always try 27 times 6. 6 times 7 is 42. Write the 2, carry the 4. 6 times 2 is 12. Plus 4 is 16. Well, I guess that actually worked out perfectly. 27 goes into 162 6 times. 6 times 27 is 162. You subtract that off, you get 0. That doesn't happen very often, but every now and then it will. We still have more to go, so we drop down the next digit, which is a 2 here. And we have to look at 27 fits into 2. Well, 2 is smaller than 27, so 27 is not going to fit at all. It's going to fit 0 times. 0 times 27 is 0. Subtract that off and you get 2. There's nothing else to drop down, and we've reached the end of the line. So I guess we have to stop here. There are a couple of different ways that you can deal with that. One of the ways you can deal with that is to use a decimal approximation. We'll talk about decimal numbers in a couple of weeks. Another way you could deal with that is to write the result as a mixed number, as a fraction. We'll be dealing with the fractions sooner than decimals, but still a couple of weeks from now. For right now, I'm going to leave this as it is and say that 1,622 divided by 27 is 60. With a remainder of 2. Writing out fractional values with remainder like this is not useful in a lot of applications, but it is useful in a couple of different places. For example, if you are converting from inches to feet and you have something like 76 inches, you would take 76 divided by 12, which is 6 with remainder 2. I'm not going to write out the steps, but that would work out with a remainder. It turns out that that 6 is the number of feet, and the remainder of 2 is the number of extra inches. So if you take 74, you divide by 12, you get 6 feet and 2 inches. Likewise, if you are converting between ounces and pounds, the same sort of thing can show up in the arithmetic. So even though there are not a lot of applications of describing things using remainder, there certainly are a couple. With that, we've talked about pretty well all there is to talk about here, expanding out our ideas of addition, subtraction, multiplication, and division to work with some larger numbers. So take a look at the practice problems um, that I have for you related to that. And then once you feel comfortable with those, I'll see you in the next video where we will talk a little bit about larger expressions.